Bridges are a vital part of our railway network, but some are legacy structures that are starting to show their age. We rely on them to carry us to work and carry goods to market. And that demand is only going up with the growth of the economy and our need to travel and transport goods sustainably. And they need to do all of this in the context of increasingly unpredictable weather patterns. Safety checking can be difficult though, and only provides visual information at the time of inspection. With the development of digital sensors and digital twins, real-time monitoring of these critical pieces of infrastructure is now possible. But deciding what to monitor and how to make decisions based on that information is difficult. The Staffordshire Bridges Research Group from the Centre for Digital Built Britain have been addressing this challenge to create a safer, more efficient railway network.
We carried a three-stage study on 2 network rail bridges here in Staffordshire to find the best approach to digitally managing these assets, taking the learning from each stage to the next. The stage 1 was to install fibre optic sensors measuring strain on the structures and investigate the robustness of the sensing system for long-term monitoring. The sensing system is like a nervous system showing deformation variations on the bridge. Stage 2 was about processing site monitoring data to better understand the structural behaviour, such as related to time-dependent material behaviours or load distribution properties of the deck. We work with the scientists from the Alan Turing Institute to create a system for data processing. Since we are getting continuous monitoring data from these bridges, in stage 3 we focused on what to do with this data from structural engineering perspective and looked at what was most relevant and important to network rail. With the right sensing system and data management, it's possible to measure, for example, the weights of passing trains and use this information and the corresponding deformation data to assess the condition of each structural element and identify the critical components for maintenance in a timely way.
Network Rail, as an organisation, we're committed to safety. We see technology and research and development, and obviously the partnership with Cambridge, being instrumental in doing that. We're starting to look at instrumenting our bridges, and what that actually does is brings lots of benefits with not having so much human intervention. We minimise the need for people to dangle off of ropes. But what we then do is get some real-time data. We're able to see how that trends. We can then start to predict where we need to intervene. Obviously helps with planning. We don't incur costs for short-term planning, short-term works. We can actually look at longer-term horizons. So data is a key asset for us going forward.
The long-term benefit of this kind of approach to managing and monitoring assets is that you can build up a picture over the lifetime of an asset, of its behaviour and, if you like, its health. We can give it a health passport going forward. So we can monitor it from the very beginning of its construction period all the way through to its middle age, if you like. And then we can start to know what kinds of interventions we need to make on it. Digital twins are really going to be fundamental to making the best of the assets that we have around us throughout society. We're in a situation with climate change and resource constraint, and indeed the spatial constraints that we have in our island here, that we can't just continue to build new things. We actually need to make the most of the assets we have around us. And so the ability to use these modern digital techniques to really understand the condition of these things, understand how much life extension we can give them, is really important going forward.